Hi, today I want to show how to use agentic coding for creating Jupyter notebooks and alike. So as before, I'll start with root code where I've configured the API key. I will start a new task, create a new folder, and I'm using the Sonnet model called demo notebook in Git. So first, we'll create a new folder. So it says it wants to create this new directory. We allow it to create the new directory. Move to this new directory. Just use a cd command. Like we could have just done that ourselves, but let's quickly see the agentic capabilities taking us to that path. Okay, we can verify this. So what we now want to say is that now in this folder demo notebook, create a minimal Jupyter notebook, and we want to just give a good prompt. The first cell is a simple markdown telling the, let's say, the purpose, which is simple viz. Second cell is a Python one with imports. Third cell creates a simple pandas data frame. Let's say 10 rows, 5 columns. Fourth cell visualizes this data frame, and fifth cell shows some summary statistics. Okay, so as you can notice here that it started creating this Jupyter notebook. And importantly, as you can see here, we are getting the JSON structure, which is what the Jupyter notebook file format is under the hood. If you open it up in any text editor, which makes it slightly harder for us. So let's say that we save this, and so we can then also open it up. That was created using the agentic coding, and now we can just run the different cells and confirm that it is running correctly. It is indeed running. We can see this data frame created, and now we can visualize it. All right, so it says SNS is not defined, I think. Okay, so no module named cborn. I can just do a uv pip install cborn, and let's run the cells again, and we can see that the graphs are produced, and now it can produce the summary statistics, which is just df does describe. So all of this looks okay. The figure, this particular cell which is visualizing the data frame, is very expensive, seems very expensive in the sense that we could have used the df.plot attribute, the df.plot method. So maybe let's ask it to do this. In the cell where we have the visualization, use df.plot instead of ax dot plot. So it wants to read this file. Okay, let us allow the reading of this file. And it wants to edit this file. So it will need to read into this JSON structure. And now if you can see, it's making the edits. So again, if you see, the differences which are being produced are not very friendly. It's very hard to understand the things which are changing under the hood, which is a problem. And we'll now go ahead with a different implementation in a minute and see something which is perhaps better for us. So let's say we allow it to edit the file also. And now we just close this and also open this up in the notebook editor. And now let's run it again. Okay, so it's produced different kind of a plot. But anyway, the main purpose behind showing this was that the differences which are being produced, which is one of the key things in agentic coding, so that we get a sense of what are the lines of code which is being changed. It's not very trivial to understand what is changing here. So now instead, I'll say that instead of a Jupyter notebook, make an equivalent QMD file, which is Quarto Markdown, where we will have the same structure. Now, the advantage of this Markdown QMD file, Quarto Markdown, will be that we'll be able to see the differences in the changed line of code very easily instead of the JSON structure. The other benefit would be, so you can see that the differences being produced is much more natural. We don't have the JSON structure. So one is the ease of the change of code, the differences which is being produced. Second is the number of output tokens which we need to generate. So that will also be smaller because we don't need to have that huge JSON-like structure created. And now, if we have Quarto installed, it should be able to run these cells. So now you can see that it's connected to the base environment, and now we can run these different cells, and we can also then see the corresponding output. Similarly, for the next, we can then again generate these graphs. So this is also looking very much close to a regular Python file, just that we have these blocks, and we have been able to create the same thing using lesser number of output tokens and also with a richer difference, which also makes it easier if you are making additional commits and you're saving it to GitHub. You can change it, you can see the change log. And now perhaps what we want to say is that, let's say once we have run this, we are happy with the QMD, use Quarto to save or to export the .qmd to a .ipynb with a different name, say qmd to notebook.ipynb. Now it will have to run some Quarto command in order to change this .qmd, export it as ipynb. So it says that we have to move into that specific folder and then use Quarto convert .qmd, and then the output format is a ipynb. So it's now created this converted QMD to notebook.ipynb. We can verify this. Sorry. So let's just open this file. and we can verify that this Jupyter notebook has been correctly created. So this was a quick discussion on how we can, instead of using the IPyONB, generating the IPyONB directly, we can use the QMD and then convert it into a Jupyter notebook.